paper or pen or something to...
No, I think we're going to just do this one as a bit of like a follow-along coding, I think.
So, welcome everybody to this day 2 of the Living in Norway Colloquium 2021. So today we have the workshop. Our program is before lunch from 9 to 12. The workshop entitled Novel Tools for Reproducible and Transparent Workflows in Ecology and Evolution. So after lunch there will be what we renamed to the Living Norway Think Tank. Basically, we want to welcome everybody to participate in a discussion and think tank to get the good ideas for what we should do, what should be the priorities for the 2022 work program and onwards for Living Norway. Now we'll run this session after lunch in this room, and it's an important message for everyone that are participating remotely and want to join. Please get in touch, email or Slack or otherwise, so we need to know that you are coming and joining this session before lunch, so we have time to arrange the technical issues. We will, before lunch now, start with the first topic, which is a detailed and introduction to the Living Norway R package. So we're very much looking forward to that. We will continue with a session on reproducible workflows for synthesis of open data, which will be a joint talk by Angelin Bruls, water coach Rune Sørås, Ellen Martin, Ragnhild Bjørkås, and Philip Muster, who is doing this as part of their examination of a PhD course run here at NTNU. Looking very much forward to that. And at least Jens Åström will present how to disseminate your data and how to make them human readable. Now, but then, without further ado, I think I would like to welcome Joseph Chipperfield and Matthew Granger to present the Living in Norway R package. Thank you.
Okay, now I have to keep it very close. Okay, right. Yes, I'm getting thumbs up from our sound guys. Right. Apologies for that. Yes. So, today's workshop is going to be a bit of a weird one today because I think one of the things Matt and I were very keen to do is to go into a little bit more detail about the package and how people can use it. We got a little flavour of the Living Norway package yesterday with Matt sort of going over some of the basics of it. But it became very clear yesterday, I think, that it's definitely the case that for a lot of users that we're trying to target, we're trying to bring on board with some of these ways of thinking about open data, is that there seems to be there was talk about a lot of problems with like sort of families acronyms are the language we use as not being very sort of user friendly in that sense, that there's a sort of data management subculture, and actually some of the results from the survey that Aud presented yesterday really made me think a bit more about that, saying that actually yes, I think there are definitely quite a few big barriers right now, and there still continues to be, that smooth over some of this transition into thinking about some of these ways of handling, processing, archiving data in an open way. And I think also as well, there's been a sort of, like we said, we throw this acronym soup. We've talked a bit about FAIR data. There's been things like Darwin Corps mentioned. There's been things like EML mentioned. And so I'm hoping that today's workshop will sort of try and lift off some of the sort of mystery surrounding some of these terms. So it's going to act a little bit as an introduction to some of these terms for people who aren't familiar with them, whilst also sort of introducing our package at the same time. So we don't have a lot of time to do that, so I can't pretend it's going to be the most in-depth treatment about any of those things, but the hope is that we can at least sort of try and get a few more people on board for this. I think one of the things that sort of became apparent to me, at least, from yesterday, that we sometimes seem to talk a little bit cross purposes, where we've talked about sort of open data, making sure our data is open, and of course that's really, really important, but that's actually not the full story. Once you sort of get your data, if you go and submit it to a journal that has an open data requirement, so you put that data on Dryad or something similar, then you have made your data open. It is accessible to the public, and so that is definitely a step. But actually, it's one of the steps that we want to make. There is a lot more to meeting these FAIR data requirements than just making your data accessible and open. And I think this is something that we need to get across, that actually adhering to standards around FAIR data also requires that you take on board ideas of data standards, or sort of distributing your data in a standardized way, so that the data is more easy to index, more easy to look at, more easy for algorithms to find, so it makes your data more findable, and it also improves things like interoperability, which are these other two key pillars of the FAIR sort of the four pillars of FAIR. And I think actually so far with this workshop, everyone's been very on board with the open side of things. I think there's still discussions to be had about, you know, when and how to make the data open. But I think actually we haven't really gone a lot into the practicalities about the other aspects of FAIR data, about what tools we have to actually be able to adhere to some of these biodiversity data standards. So for some of you, you will have already come across some of these tools, and there are some very good tools that already exist. So one of the things I'm not going to pretend is that this package is going to solve everything for everyone. There's already some very good tools, and for people who are already familiar with the other tools and like them, that's brilliant. You do not have to feel obliged to learn about the package at all. It's just that we wanted to create another option for users, and I think I talked a little bit about yesterday with some people. I think the users we were trying to target with this package are we already have some existing tool sets to help us with adhering to FAIR data standards. One of these tool sets that people might have heard of is the integrated publishing toolkits that GBIF produces. So if you want to put your data out on GBIF, many of your institutions might have a local IPT server where you can publish your data on that, or there might be a sort of nearby node that you can publish your data on using their IPT installation. And that already exists, and that already has, I think in my mind, a reasonably good user interface for helping people try and get their data into these standardized formats. But I think it's still one of these things that still tends to be something that like the data managers from each institute focus on. It's not something that necessarily many researchers interact with directly. And there's a few reasons for that. A lot of it, like we talked a bit about this yesterday, saying that actually it's a sort of time issue. The researchers are pressed for time, and what they can't do is learn everything all the time. And so at various institutes and such as ours, we are blessed with having a very good department that specialise in handling these data and processing them for us in a fair data standard. Now, that's great, but the slight downside to relying on that is that works very well for large projects where you might have a good budget, where you can budget for some people to handle that data for you and do the processing for you. But there's a lot of sort of small to medium-sized projects that might not have huge amounts of data in and of themselves that sort of are falling through the cracks, I think, under the current system. And these projects may not have a budget that's big enough to hire sort of IT professionals or data management professionals to help you process the data. And so it's down to the researchers themselves to do it. And we talked a little bit, I remember in the last year's colloquium, we talked a little bit about this, where we talked a little bit about the master student effect. And I think that's a good one, where I remember Vigdis making a list of her master students, of how many master students she had had over the years, and how many of those she still had the data for. And the attrition was quite high. I think she had about 50% loss. And I started thinking about it, and I thought about my own master students, and I had an even worse percentage loss of data. The master students that they produced their thesis, some of them might be published, and if they publish it in a journal that has an open data requirement, then that data is open at least. But for students who aren't able to publish for whatever reason, often that data would sit in a drawer, and there certainly wouldn't be the budget or the investment ability to be able to sort of standardize that data and put that on some repository. And because these data sets are quite small and they're to answer very specific problems, then it also meant that they weren't easy to sort of do as one big batch either, to collate them together and then go, okay, I'm going to sort of publish all my master students' data. So I think collectively all these small projects amount for actually quite a lot of data loss. And so I think when we developed these tools, in my mind, these were the sort of projects I was targeting, these sort of small to medium-sized projects, whereby if the researchers had some R tools and they were competent with R, then they could at least maybe do this themselves. Like, you know, I don't think we got to a stage yet where we could be getting master students to do it for us as part of their thesis submission. Maybe that's a future goal. But for now, I think at least the supervisor, if they are confident in these tools, it wouldn't be such a big task for them to go to the next step and meet all these fair data requirements when they publish. So I've talked a little bit generally. Right, let's get into the specifics. So Matt showed this slide yesterday. I'm going to show it again because we're quite proud of it. So whenever we talk about data standardization, I think people sort of tend to get the wrong end of the stick a little bit. I think everyone has a unique data set. That's a given. Everyone's data looks very different from everyone else's. Everyone's got like, well, I've got my own unique monster here, and it's very different from this data set here. So I don't really understand, like, I think there's a lot of resistance inherently to standardization, because I think there's this idea that like what you're trying to do is make those two look the same. You're trying to put like a common format over them and say, okay, once we can get the sort of data templated according to this nice thing, we can sort of fit it, and then we lose a lot of information in my data because I'm only interested in the sort of commonalities between them. And actually, that's not really what we mean with these standards. Or at least I don't think that's a very good analogy. I think a better analogy is what we're trying to do is make little labels that we can hang on our unique data sets. And so we can say, okay, well, these data sets have different numbers of eyes. And the eyes look quite differently. But there is an idea of what an eye is. There's a common idea. And so if we can come up with a sort of definition for an eye that makes sense, then we can now put labels on these eyes and then identify them as eyes. So now when someone comes across your unique data set that might look very, very odd, it can at least go, okay, 2 eyes, 2 legs. They can find certain things about your data set very easily and very quickly without having to dig down into the minutiae of your data set to find these things out. And so the next question then, of course, becomes like, well, who gets to decide what an eye is and what a leg is? And this is where some of these standardization committees come in. There's a lot of effort going on in the biological realm from various standardization communities to come up with standards and to come up with definitions for these things that sort of make sense and that there's an agreed upon standard. So we've talked a little bit about one already yesterday. Dwc is one, and they're responsible for a number of standards, one of which is the Darwin Corps, which we've also talked a little bit about. This committee gets together and they make decisions about what an eye is, and they come up with a decision of an eye, and then they say, okay, well, given this definition, now researchers can then decide for themselves and hang that label on that feature of their data set if they believe it falls within that sort of idea of what an eye is. I think I've made it sound very top down, like there's some big standards committee sitting in the sky deciding things, and it's really not that at all. In fact, actually, I think the Dwc conferences are very welcoming. They very much encourage a lot more participation, and if you have a bizarre new data set that really does not have any features, that has no concept of eyes or legs, has something brand new, then they very much encourage you to join Dwc's working groups and come up with these new definitions and try and expand some of these standards to account for these new weird and wacky data sets as they arise. But that's basically sort of how we, or at least I think that's a better way to think about standards when in the context of data. So it's less of a template to put your data in, and it's more of a language to describe your data set, I think, is probably a better analogy. So in the Slack chat, I put a link to this website. So this is going to be, it's a bit difficult because we were asked to do a workshop, but of course we're in an auditorium. And so it's a bit difficult to do like a sort of proper workshop exercise in an auditorium. So this is going to be like a bit of a weird hybrid where I'm going to go through code, but we're not going to be able to all go through the code together realistically. So I think what we'll do is I'll go through like a sort of workflow of how we've envisaged it according to the R package. I'm going to go through an example using this on an example data set. So the data set I'm using is the Dwc data set, which is this, it's the bird data set from the terrestrial overwalkings scheme that we run here at NINA. And we're going to go through that one. It was a nice data set because it wasn't too large. So people could download it without us killing the network here. But also, it also had a couple of nice features that meant that we could show off some aspects of the package. And it's also freely available from our IPT server as well. The code will... Oh, yes, I know. I have a cancelled meeting, yes. Okay, so what I'll do is I'll go through this workflow. So this file I'm going to go through is actually, for people who are interested, it's a processed R Markdown file. But if you are not into R Markdown, you don't have to worry. You do not have to be an R Power user for this workshop. In fact, the idea is really, if you know something about R, then we hope that you can follow along. If you can't follow along, you can feel free to ask us questions. I think the best way for asking questions is probably to do it through the Slack. Matt is keeping an eye on the Slack channel, and what we'll do is once a few questions pile up, we'll sort of take little pauses, and I'll address the questions probably in blocks. I think it's probably the best way to go, I think. And then hopefully by the end we have a bit of time for a bit of discussion about the package as well, because there are some design decisions we haven't made yet. There's definitely areas we can go, and so actually it's really useful to just have people's feedback on this, like what's confusing, what's complicated, what do people like about the package, what do they not like about the package. Because one of the key motivations for doing this is to try and bring on board more users who wouldn't otherwise go through this process. So if I get to the end of this talk and none of you understand what the package is supposed to be doing or how to use it, then I've done my job badly. But it's also useful for me to know that I've done my job badly so that we can try and sort of make refinements to the package or maybe have another crack at this another time. So I'm afraid you're my guinea pigs this year. So we talked a little bit about Darwin Corps, and I've talked about it just now, but the reason why we talk specifically about Darwin Corps is because it's sort of, it's a quite ubiquitously applied standard. It's not the only standard. There are plenty of others, and we already talked about other standards and extensions yesterday as well. So I'm not going. This certainly isn't the only standard. But the reason why we started with this one first and supporting this standard first with our package is because it's the most widely used, and actually mainly because GBIF uses it for their backbone. And I think for most sort of researchers, I think most people, when they're thinking about sharing data, they're really thinking about trying to get it indexed on GBIF. That's really sort of, I think that's sort of become a bit analogous. Now, there are, of course, other biodiversity indexing databases, and there are, of course, other standards. I think the plan was that eventually that we might be able to support those under this package as well. But for now, at least, with these early steps, we've talked about specifically about Darwin Corps. One thing we need to separate is between the standard of Darwin Corps and Darwin Corps archive files. Matt talked a bit about this yesterday. I think this is something that sort of can trip up early users. So when we talk about just Darwin Corps, we're talking about the standards. So we're talking about the language. We're talking about, like, you know, the idea of these labels that we're hanging off the data set. It's a sort of a conceptual, more of a conceptual thing. You're saying, okay, when we talk about Darwin Corps, what is an event? What is an occurrence? What do we mean by these ideas? When we talk about Darwin Corps archive files, that's actually a particular file format that allows you to share data and metadata packaged together in a way that, like, because of its name, adheres to Darwin Corps standards, but also, yeah, it's a file interchange. So that's where you're actually sharing your data. So if you're sharing your data in a Darwin Corps archive file, then then by doing that, your data is almost certainly adhering to the Darwin Corps standard. I can't think. There might be some weird edge case where you manage to make an archive file that's not Darwin Corps compliant. I can't imagine how that would happen, but maybe maybe people who know better than me on that might be able to do that. But in general, that's the aim of the archive file. And the main thing about these archive files is that it's this sort of like nice little package that puts everything together. It puts all your data tables together. It tells you how they're sort of defined under this standard, and it also puts together your metadata all in the package. So that's just by sharing this like archive file, you're actually sharing all the information you need to share about your data in one go. So it's quite a neat way of transferring data, because you don't if your Darwin Corps archive file is legit, then you shouldn't be losing your metadata. Things shouldn't be missing from it. You don't end up with a situation where you're like, oh, hang on, there's this other table that I forgot to send you. It's not like it's not a sort of messy thing of tables and then the description of what the columns in those tables mean somewhere else. Like, this is all packaged nice and together, and then it also meets these biodiversity standards. So in general, I think for most researchers, we tend to think of this as a bit of a sort of dream scenario where we want our data to end up, is something that is like this file format. And that's mainly what the tools in this package are aiming to, is to help you go from your data as a collection of data frames and some metadata, which might be you writing up a sort of data paper, say, that describes your data sets, and going from those ideas and getting through towards this product here. I'll just take a drink. So, what do I mean by Darwin Corps archive files? Well, I won't go into all the text here, but I think this figure is a good way of explaining it. And this is my not as good version of GBIF's figure for this. They have a nicer looking figure. So I tried to recreate it, and mine doesn't look as nice. But in general, what is a Darwin Corps archive file? Well, I said earlier, the great thing about the great thing about these archive files is it's not a mess of files. Well, actually, that's not quite true, because really all an archive file is a zip file. And in that zip file is a mess of files, actually. But there are some things that make it a bit less messy. So this is your sort of data here. These are your tables. And usually what you have to do is have one of these tables designated as your core table type. And I'll explain a little bit about like how you decide what your core data table type is. But that's the data table that sort of like everything else hangs on. So it's like what is the basic unit that you are collecting as part of your data set. And one of the crucial things with this core data table, one of those columns has a special use. It's a ID column. And every row in that ID column in the core data table must be unique code. So actually sometimes that helps you decide what your core data table is going to be, because if you're thinking about like, okay, which of my tables needs to have a unique identification code, that's usually a good clue as to that probably should be your core data table usually. And then you have some other columns, as many as you like, for your data set. And then that for many data sets, that of course won't be enough. You'll have some other data that you want, that in this parlance we would call extension data tables. And these are tables that would also adhere to some standards, and they would instead what they do is they would like extend or create or contain more information about rows in the core data table. So I appreciate I'm talking a bit conceptually right now. So to give a practical example, one example could be that every single row in this thing is a sampling event. Like it's a time when you went to a place and you sampled something. But when you went to a place and you went to a certain time and place and you did a certain experimental protocol, but then you actually collected a few different species. So one thing you could do is you could have one column for every single species you collect on that row. Or what you could do under this concept is you could have another table that has a row for each of the different species you collected, with one saying how many of each you collected, for example. And then in these extension data tables, these also have an ID column. Every table needs an ID column, but the ID column, this one in the extension tables, acts slightly different. What that does is that ID column basically gives the ID number in here that relates to. So, for example, if you had the sampling event and you saw 3 species, so the sampling event would be this unique row that would have a unique ID code, and then you saw 3 species, so you then have 3 rows in this data table for each of the species. But that code we've duplicated 3 times because that says each of those 3 relate to this one row here. So in extension tables, this ID doesn't need to be unique. In fact, quite often isn't, in fact, actually, because often you might be describing multiple records at the same sampling event. And so when we're talking about how we structure data, this is how the intuitive schema has been set up for these Darwin Corps archives. So this gets called a star schema because they tend to think about this being in the middle, and then these extension tables all are things that come out into it. So actually, in the GBIF help files, they actually have a star around it, but I'm not a good graphic design artist to do that without having too much white space. So mine's less of a star schema and more of a pyramid schema or something. I'm not really sure. Bet pyramid scheme sounds a bit dodgy. But that's obviously not enough. So you have all these tables, that's lovely, but if this all was what a Darwin Corps archive first was, all it would be a zip file of your data tables, right? Like you haven't really done anything with this. You haven't said anything about how each of these columns relate to standards, and you haven't really said how they link to each other. This is where the other 2 files come in, and there's 2 of them. One of them. So they both get called they both have annoyingly similar names. One is the meta file and one is the metadata. So the resource metadata is what we commonly think of as being the metadata. When we talk about that's like your description of the data set. The meta file technically is a type of metadata in a computational thing, but it's not what a biologist would think as metadata. This one actually, this meta file basically explains like which of these columns in each of these tables are the ID columns, and it also says, okay. Each of these columns, do they relate to ideas in the Darwin Corps standard? Like, does column B here, can we put labels on some of these columns? So a little bit like with the monsters, we're hanging labels, eyes and legs on our data set. The meta file is basically telling us what labels we can hang on our columns. And so we can relate that to a standard. So now our columns mean a little bit more, in a sense, because we say, not only is my column saying this, but actually in a sort of standardized context, it means exactly this. And I can link to a definition that's been well defined. There'll be a nice like IRI where people can look up that definition of that. And so therefore you've now grounded your data according to a standard. And so the meta file basically lists all of these little column tags effectively. And then next to that has this resource metadata file. And this basically is what we more commonly think of as biologists as being metadata. So this is like the things where you describe your sampling methodology. You would explain like who created the data set, who's responsible for maintaining it, who wrote the metadata for it, what access rights there are around the data set. Basically all of that type of information would go in this file, basically. And this is the thing that's given Matt and I a headache, because this file in the Darwin Corps archive adheres to this ecological metadata language, EML, which is a really thorough and really good language to describe ecological metadata. However, I also think it's not terribly user-friendly. I think it's fair to say, I don't know how many people here experience having to try and hard code EML files, but it's It's not fun. It's quite frustrating, actually. The standard is huge is the big problem. It's not so much that it's. I think as a novice coming into it, you're like, oh, let's learn some EML. It feels like you get thrown directly into the deep end because it covers everything. It covers museum collections. It covers like things that are on loan to other museums. It has this whole, like, basically it feels like you get thrown into this deep ocean of metadata tags. And it's very hard actually to work out even how to get your first metadata. There is some nice documentation. They do give you some pointers about like my first metadata file. But there's this very middle ground between my first metadata file and then this sea of tags. And so this has been what's given. So the reason why, like last year, Matt and I said, yeah, we're almost done. We just need to do the metadata. And then we're here a year later. We're like, we've just got our first implementation of handling the metadata. And I still think actually our implementation, like I think it's a step in the right direction, but I still don't think we've got to the point where it's like super user friendly. I think we're going to need to have a few more development cycles before we get to the point that because ideally, I think, realistically, I think to get people who are not comfortable with these type of things on board, I think you want to disguise as much of the EML as possible. I think you want to get people to make EML files without realize they're making EML files. That's the idea. Whereas I think Darwin Corps is big, but I don't think it's as scary as EML, or at least in my opinion. So that's like a general sort of introduction to what our package is trying to do. Okay, so let's get into specifics. So I've talked a bit about generalities, and I think it's good to sort of just dive into some examples because I think that's when it starts to become a bit clearer. For people who are interested, like I say, this is a HTML that I've created from our Markdown file. And so I have also put links to the original R Markdown files for people if they want to run the code along with me, which is basically if you open up an R Markdown file in R, so this is like a little sort of mini primer on R Markdown. R Markdown files, all they are text files. Like they're just text files, except they're text files with these blocks of code dumped in the middle of them. And it's quite nice because what you can do is you can sort of render these R Markdown files and turn them into HTML files. You can turn them into PDFs with lots of nice figures. You just have to sort of use this sort of R Markdown language, which is it's fairly rich, but it's also not super complicated. Like I feel like sort of R Markdown is designed to be sort of quite accessible. It's not like LaTeX or some of these other things which are quite heavy languages in comparison. So if people want to, they can try and follow along. I'm going to be working from the sort of. I'll probably be sort of flicking backwards and forwards because I sort of want to show you it running in real time whilst we do this. So I'm afraid that there might be a bit of flicking back and forth. But the very first thing we do, so just to get to the same point we are, is, as Matt said, we have now finally got to the point where this works, or should work. If it doesn't work, let us know. But at least on my machine, this works. It gives us a couple of warning messages still, but it does at least work. I made the mistake of upgrading my R installation just before here, so now I get more warning messages than I did previously. But yeah, so for people who are not used to this is basically just installing the Living Norway package from our GitHub server. Eventually, the plan is that we'll try and go through CRAN. So eventually, this line should be replaced with a sort of install packages call. But for now, for people who have written packages before, making something that's CRAN compliant is quite a lot of work, and we're definitely not there yet. We will definitely need to iron out some more stuff before we're ready to go to CRAN. But for now, that's where our package is held. Then once you've installed that, then it's just a case of going library Living Norway R, which will then import all the things you need to do all the stuff we're doing from here. It's got a few dependencies, so for people installing it for the first time, if you already haven't installed some of the sort of dependencies, it might take a while. In particular, it's quite reliant on the XML2 package, and I think that one's quite a big package generally. So just to warn you, if people start doing the installation now, it might be like a good 10 minutes before actually everything's installed. Okay, so once you've installed and loaded that, then what happens is, what it does is it creates these new like object types in R for you to handle some of this Darwin Corps data with, basically. And so in a very computer sciencey way, it creates these extra things called classes. Now, I'm not going to go into like R object-oriented programming, but what do I mean by a class? Well, it's just a type of data. Like if you've used R before, you've sort of you've used different object types, you've used lists, you've used data frames, you've used vectors. These are just different types of sort of data structures that can hold different types of data. All we're doing is we're adding to that vocabulary. We're adding some more different data types. So as well as having data frames, you now have these extra terms. And these are the 4 key ones that our package introduces. One is called DWC term, or short for Darwin Corps term. You as a user will probably not interact directly with this, so probably don't need to worry too much about this on the first pass of the package. This is just more for holding information from Darwin Corps standards about a term. So when we talked about these tags earlier about like what an I is, this term just like basically carries that I definition around, so you can look at it in R, and so you don't have to always be checking back on the Darwin Corps standard. And these term objects get like loaded into the background and get called up, and you can look at them when you want to. For power users who want to define their entire own biodiversity data standards, you can also define your own terms as well if you want to create your own biodiversity data standard. I'm guessing probably no one here wants to do that, but for people who want to do that, like that, we've added that sort of flexibility so that like it's mainly to future-proof the package as standards expand or as new standards come to the fore. Then there are ways to sort of manually add some of these terms. The next one, and this one is actually probably a very key one, even though it sounds really boring. It's called DWC generic. So we've given it the most boring name, but it's probably the most important class that we add. Basically, the generic class, we called it the generic class because basically it's like a super class. It handles all the data tables. So all those things in the Darwin Corps archive, all those data, either they be core data tables or extension data tables. If it's a type of like data table, then it's a type of DWC generic. I call it a super class because actually all our data tables are type of DWC generic in Darwin Corps, but then they've all got their own like unique specialization, their own flavor, depending on what type of data table they are. So if you're doing, we'll come back to explaining what I mean by an event core, but if you're say doing an event core, Darwin Corps archive, you would have a core data table that's of type event. And so then the subclass of this would be GBIF event in that case. And so there are loads and loads of subtables. We've done one for every single type of table that is supported by GBIF. Well, that's not quite true. Every table that's gone through the development that's supported by GBIF, because GBIF has like GBIF has a lot of registered extensions. So if you go on the GBIF website, there's actually a link. I've created a link hyperlink somewhere in this text. If you go onto it, you can load up GBIF's website, and it'll tell you all the different data tables that it accepts. It has all these different registered extensions. It's getting quite large now, and it's going to be beyond us to go into all of those separately. So what I can say is we use this very simple naming convention. If it's on GBIF, the way then the subclass is called GBIF followed by its name. So if it's an event on GBIF, it's GBIF event. If it's occurrence on GBIF, it's a GBIF occurrence. The reason why we've prefaced it with GBIF is because actually, in principle, other biodiversity data repositories might have slightly different ideas of what an event or occurrence is, and so in those cases, we're future-proofing ourselves for the idea that if GBIF had a different idea of what event was from say a different biodiversity database, then we could support both. That we wouldn't have to we wouldn't end up with terminology clashes. I talk about GBIF event a lot, and I think probably it'll be the most used subclass probably for most of our data types. But basically, that's the way to think about it. DWC is this generic, is this like superclass. It's like you will never probably make a DWC generic object yourself, but what you will do is you'll probably make lots of their subclasses. You'll make something that's been sort of derived from that. That's got its DNA basically. Then we have this DWC metadata class. Unsurprisingly, this is a class for handling the metadata. So this is it's basically, I made this class to try and hide the EML from all of you. Its job is to try and create, the idea behind creating this class was to try and create a friendlier interface to metadata than having to deal with raw EML tags. You'll see later that we've partially succeeded. I wouldn't say I think it could probably do with a more development cycle to make it a friendlier interface, but I think it's less spiky than the EML, or the more EML is. And then we have the DWC archive, and the DWC archive class is basically just that final package, them all packaged together. It's basically it's a class that will have a metadata object in it and a few DWC generic objects in it, all stuck together to make an archive class. And so all of these data types collectively will help you you'll be able to use them in your workflow for dealing with data for these types of things. How important is it to have similar documentation / format for spatial data as with DWC? Are there efforts in this direction? Do you